students, hope you all are fine. In today's video, we are going to talk about a basic topic that is stability. Most of the students are confused regarding stability. They have just memorized the definition and they don't know what is the meaning of duplet, they don't know what is the meaning of octet, electronic configuration. How does electronic configuration tells you that whether a given element will be stable or not? All these things we will discuss in this video. So let's start with stability. Actually, this topic is of smaller classes, but even student of higher classes have many doubts regarding this topic. So we will discuss it today in brief. I hope after this you won't have any doubt regarding stability. So let's start. What is stability? When is a thing said to be stable? That we have to discuss. Now let us move on to a new topic, that is your chemistry in your life right now. How is chemistry related to your real life conditions? See, you, me, everyone is fighting for stability. Whether it is you, whether it is me, or whether it is even an animal is fighting for stability. Stability means a state where you have less energy. In terms of science, stability means a state where the energy is less, down. Okay, so whenever something radiates energy out, it becomes more and more and more stable. This is the linking of energy with stability. For example, you can think that right now you are a student. So being a student, you have to run for tuitions, you have to run for coaching, you have to run to school. It means you are continuously running. Whole day you are running. You have to play also. All these things are there. So as a student, you have that much things to do. It means the energy content in your body is very high right now. This is just an example. Do not link it to scientific terms here. That is just an example. So as a student, you have many things to do. So continuously you are running. It means you are unstable. Stable means if you are if you are at a place, then it is said to be that you are right now you are stable. But if you are continuously running to school, then tuition, then coaching, even in the school, going to washroom, tiffin, then your PT period and all, every time you are running as a student, you are running. But after some time, when because of all these things, your tuition, your studies, your coaching and all, when you will get a job, then you say that I'm stable. Because after a job, you won't go for a tuition, you won't go for a coaching. For what you did, all these things was a job and you got it. So now you're stable, now you're not running. It means for instability, energy content is always high. And for stability, energy content is always low. So in this way, you can link this. Through this example, you can link that as a student, that much energy, so instability. After a job, everything is okay. Now fully stable, less energy. So what we get from this, you don't have to remember this example. Do not memorize this example. This was just for making you understand. Now, what is the overall conclusion that we are going to write here? The overall conclusion is stability implies an element is always in low energy state. Now, can you tell me some of the elements which are stable? Definitely noble gases. It means noble gases are always in a low energy state. But if I talk about something reactive like sodium, sodium is reactive, you know. That is why when sodium reacts with water, it releases enormous amount of heat because it is unstable. Unstable means high energy content. Sodium has high energy content. That is why it gives that reaction. But noble gases have low energy content. They don't have that much energy because already I told you stability means low energy. Unstability, like sodium, implies high energy. So definitely sodium is in a high energy state. Noble gases are in a low energy state. So remember, stability linked with energy is high energy, low stability. Low energy, high stability. Which more stable, low energy, less stable. If you, simply we can write that stability is inversely proportional to energy. This is the final thing that you have to remember. If something is stable, it means its energy is low. If something is unstable, it means its energy is high. So stability is inversely proportional to energy. Now many of the students, I think, don't know what is the meaning of inversely proportional. Inversely means if a quantity increases, the other quantity decreases. And if that quantity increases, so this quantity will decrease. It means whenever stability increases, energy decreases. If stability decreases, energy increases. This is the meaning of inversely proportional. One is directly proportional, in that both the quantities behave in the same way. Suppose these two things were directly proportional, so more stability, more energy, less stability, less energy. That is the meaning of directly proportional. But we are talking about inversely proportional. So more stability, less energy, less stability, more energy. So I hope now you know what is the link between stability and energy. An element will have low energy if it is in stable state, and energy will have high energy if it is unstable. Now ways to achieve stability. How to achieve stability? There are two ways which is in your course right now. They are duplet, another one is octet. Look at it very carefully. There are many places where you cannot use octet. There are many places where you cannot use duplet. So look at it very carefully. What is duplet? Duplet is linked to only first shell, that is K shell. K shell duplet. Octet is linked to other shells other than K. So if it's other than K, then you can get octet. Very easy. Duplet means K shell, octet means other than K shell. Now duplet means double. In that way you can remember. Duplet means double, means 2 electron. Octet means octa. Octa means 8 electrons. So 2 and 8 you have to remember. These are the numbers which gives stability. So ways to achieve stability is acquiring duplet state or acquiring octet state. Now again there are two ways to achieve duplet or octet. They are donation of electron, or you can accept electron. Again two ways are there to get stable. You can add electron to become stable, or you can get to achieve duplet or octet state, or you can donate electron to get into duplet or octet. It's very easy. One word question or two word question. What are the two states? Duplet and octet. What are the ways to achieve stability? Either donate electron or either accept electron. Now how to know whether I should donate electron or I should accept electron? Again it is very easy, but for that I recommend you to learn at least atomic number from 1 to 20. This is must for you up to class 8th. I'm telling. After 9, 10, as much as you can remember, and even if you can remember the whole periodic table, that will be good for you. But up to 8, at least learn 1 to 20. That element name you should know. Okay, because after this I will tell you how to take out electronic configuration. So let's move. After that you will get to know how to achieve duplet and octet state. Okay. So let us take an example. Let us take the example of magnesium. Atomic number 12. Give its configuration. It will break as 2, 8, 2. This example I will solve fully. After this, I hope you will understand how I'm going to solve it. In a hurry way I will solve it, in a fast way I will solve it, so that you will get to know. But first example I will take enough time so that you can understand it very properly. Okay. Magnesium atomic number 12. Configuration 2, 8, 2. Now how it came? See. First shell is K shell. Remember, K shell can accommodate only 2 electrons. That is its capacity. Formula is twice n square. And this way you can remember how to know the maximum. See, maximum is different thing. How many electrons you can fill here, that is different. And how many electrons should be there for stability, that is different. I hope you understand. How many electrons can come, that is 2n square. But how many electrons should be there, that depends on your stability, means duplet or octet. Just for an example, let's take an example. Suppose there is a bed. So three-person can easily be accommodated in that bed. It is very easy for three-person to sleep there. But three means a congested street. Okay, it is okay that three can adjust there. No problem, three can adjust. But are you stable in that state? No, you are not stable in that state. For you, the stability is single. If in that bed I sleep alone, it will be stable for me. So that is the meaning of accommodation and stability. For stability, you should sleep alone in that bed. But if we come to make some adjustments, then three can also be there. But with three, there will be instability because there won't be any space. Okay, so you will feel awkward to sleep there, or you will have many problems. Okay, so this is the state. How many you can fill? How many electron you can fill? 3 for example. But what is the best state? If you sleep the single, that is the best. So this is your, how many you can accommodate is 3. But how many should be there for stability? That is 1. So in that way also, there are many things which you will get here in various shell. For example, in third shell, according to this formula, look at this formula. Now you will get to understand 2n square. So third shell means n equal to 3. Here n means number of shell. For k, n1. For L, n2. For m, n3. So I am talking about third shell, m shell, n equal to 3. Let's write the formula. 2, 3 square, 2 into 3 square, 2 9 is 18 electron. It means third shell can have 18 electrons. I can fill 18 electrons there, but again, stability depends only on a duplet and octet. It means even if I can fill 18 electrons in third shell, I won't fill. There will be 8 electrons because I need stability. Focus on this. You can fill 18 electrons in third shell, no problem with that. Just like 3 people can adjust in a bed, no problem. But for stability, you should sleep alone. And here, for stability, we should keep only 8 electron. Why? Because 8 electron means octet. As I told you, other than K, you have to think about octet. You cannot think about duplet. This is not a duplet state because this is not your K shell. This is not K shell, so you cannot say that, sir, this is already stable. Because this is duplet, octet and duplet. No, this is not duplet. Duplet is only for K shell. I hope it is clear. Okay. So even if you can fill 18 electrons in third shell, you won't fill. Why? Stability will be with 8 electrons. So once you get the configuration, now from here, how to know whether it is stable or not? See, if in the valence shell, focus very carefully, if in the valence shell there are not 88 electrons, if in the valence shell you are not finding 8 electrons other than K, in K 2 electrons, it's okay. For example, hydrogen. For hydrogen, valence shell should have 2 electrons to get stable. Don't think that atomic number of hydrogen is 2. No. I'm telling that hydrogen will become stable when its valence shell will have 2 electrons, but hydrogen's valence shell contains only 1 electron. So for the first shell, we can talk about duplet. It means if hydrogen add 1 electron from somewhere, it will become stable. No doubt in that. It will become stable by just adding 1 electron because it will come into duplet state. And this is also first shell. So for here, we can think about duplet. So what will hydrogen do? Hydrogen will try to take 1 electron from somewhere so that it can have duplet. Mostly it go for covalent bonding, like it will make a covalent bonding with chlorine, HCl. So 1 electron Cl will take and 1 electron H will take, and they will make a covalent bonding, and hydrogen will get duplet. Okay, so we are not talking about structures here. Okay. So hydrogen 1 can add 1 will become, suppose hydrogen adds 1, then 2 electron. Yes, now it is stable because this is the first shell containing 2 electrons, means it has achieved duplet state. But what about magnesium? 2, 8, 2. See, the valence shell does not have 8 electrons. So without thinking that much, simply write this particular element is unstable. This particular element is unstable. It doesn't matter what is that element. If it does not have 8 electrons in the outermost shell other than duplet, other than K shell, then you will say it's unstable. Why I'm talking only about that much about octet? Because most of the element you will find in this condition. This duplet state is only for some of the elements, 3-4 elements, which are interested in that state. Otherwise, maximum elements are interested in octet. So focus more on octet. Okay. So let us talk about magnesium. In the last video, so I think in the second video, I have already discussed about this, but again I'm discussing so that you won't have that much confusion. Magnesium 2, 8, 2. Two methods are there again. Either it, okay, so 6 electrons are here, or it will go for removal. Minus means removal of 2 electrons. Okay, removal of 2 electrons. So 6 electrons are here and 2 electrons are here. Possibilities. Either add 6 electrons or either remove 2 electrons. Two things are there. Okay. So 6 electrons means 6 transactions. 2 electrons means 2 transactions. Now, I hope you can understand which of the path is easy. According to chemistry, the path which contains less energy, that is more preferred. So here only 2 transactions, so this will be the preferred way. It means magnesium will go for a loss of 2 electrons. Mg will lose 2 electrons. And remember that losing means plus charge, addition means negative charge. Okay. Now magnesium will lose 2 electrons. So what will happen? See the configuration 2, 8, 2. 2 electrons gone. Now they are not there. So now it achieved the configuration of neon, nearest noble gas 2, 8. Why? Because it loses 2 electrons. So Mg is written always as Mg plus 2. You will never see Mg as plus 1. Plus 1 won't make it stable. Why? With plus 1 it will become 2, 8, 1. Again unstable. So magnesium ion always exists as Mg plus 2. Okay. Let us talk about some negative type of ion. For example, sulfur 2, 8, again 6. Here also 6 is the last. Okay. So 2, 8, 6, same condition. Now, two ways, either remove 6 electron or from somewhere add 2 electrons. Two possibilities are there. So definitely low energy will be in this case. 2 transactions, 2 electron means 2 transaction, 6 electron means 6 transaction, minus means removal, plus means addition. So it will go for this path. Why? Only 2 transaction means addition of 2 electron. So addition always gives you negative charge. Here see, magnesium went for losing. So plus, sulfur goes for addition. How many? 2 electrons. So S2 negative. Sulfur is written as S2. It is very easy. But you should know atomic number, plus you should know how to break it. Okay, means electronic configuration you should know. So S2 negative. So I hope now you would have understood that how to know whether some element is your stable or not, whether it is stable or not. Let us take some already stable elements like argon 18, 2, 8, 8. Now look at the valence shell. Look at the valence shell. Already 8, octet state already is there. So do you think that it will go for any reaction? No. An element go for reaction when it wants to achieve octet. It is already in octet state. Already in octet state. So it won't go for any reaction. Okay, won't go for losing electron. Neither it will go for adding any electron. It means argon is already stable. Let us take an example of duplet state. Helium. K shell with 2 electrons. K shell with 2 electrons. It means duplet achieved. So already stable. So helium is also already stable. It doesn't go for any of the reactions. Won't react with any chemical species to either gain electron or to lose electron. So in this way you can get to know that whether something is stable or not. Okay. I hope all these things are clear to you. These are not very big topics. For the beginners, those who are beginning into the chemistry right now, for them it is a little tough. But for those students who will watch this video for clearing their concept, I hope they will clear it within few minutes. Okay. But for the beginners, it will take a little time. So what we studied today is what is the meaning of stability, then link with energy. Why I'm telling you all these things at the end, that what we have studied, so that again you can think that what we studied in this topic, what we studied in this topic. Okay. So first thing we study was stability. Second was what is the link of stability with energy. High energy, low stability. Low energy, high stability. Okay. Then ways to achieve, how to achieve configuration. Sorry, how to achieve that configuration means duplet state or octet state. How to achieve that. Next, after achieving stability, we studied about electronic configuration. What is the use of electronic configuration? If in the last you get 8 electron other than K, then it's unstable. If you get 1 electron other than in K, suppose there's 1 electron in K like hydrogen, again it is unstable. What about stability? According to electronic configuration, if 2 electrons in the K shell, and K shell should be your valence shell. Okay, so if K shell contains 2 electrons, it's stable. If other shell contains 8 electrons, it's stable. Example I gave you for helium, 2 in the K shell, and for others like argon, 8 in the octet. Sorry, in the last shell means other than K shell, octet state is maintained. So others are also stable because they have octet state in the valence shell, and helium has duplet state in the valence shell. So how electronic configuration tells you. And next we studied what should be the charge on any ion. Why sodium is written as Na plus 1. Now I hope you will get to know after taking out configuration. Already I told you why magnesium written as Mg plus 2. Why sulfur is written as S minus 2. I hope it is clear to you now. So I hope next time when someone gives you any of the element and tells you what is the charge over it, you will easily tell. But remember, for other elements which are already stable, there is no charge. Okay, so helium is not written with any charge. Helium only this much. Then neon, same. Argon, krypton, xenon, radon. None of the gases will have any charge over it because they are already stable. Neither losing electrons nor gaining electron. So in this way, you can clarify all your doubts regarding stability. And I hope from the next time when you get into something, you won't be confused that what is the meaning of duplet there, what is the meaning of octet there, why it is reactive, why other element is not reactive. All these things will be clarified by focusing on these points. So this was basics about chemistry that every student should know when they are beginning chemistry. Okay, so I hope all things will be clear to you. So keep growing,